Alright guys, Mr. B here again with another video on drawing molecules with Lewis dot structures. We're going to be using another simulation to do this. So this is in Schoology, but I'll also put it in the description for the video. But we're going to click on this. We are going to go to the website. Here we go. So this one, it's going to let us build molecules by grabbing these Lewis dot structures off on the side and then dragging them in here. So like we can grab this hydrogen and drag it in. And it says these ones are single bonded molecules. It says try building the molecules below. Click on the formulas to see the answers. So if we click on these, I'm pretty sure it's going to show up on the right side here what that molecule looks like. But I obviously want to build it first, and then I want to check to see if I'm right. So I'm going to try building H2 first. I believe it says to spin the electrons around, click on them. So like if I wanted to move this electron to a different location, I can click on it. Now with this simulation, it doesn't really give you the correct answer. Like once you've got it, it'll tell you if it's right, but you can build it and then you can check to see if you're right. And then if you're not, you can see where you messed up. So we're going to build H2, which means I'm going to need two hydrogens like this. With hydrogens, they are going to want to share each of their electrons with each other. Remember that hydrogen at most can only hold 2 electrons, so it makes a single bond. And if they are sharing their electrons, then they're probably going to be something like this, where those 2 electrons are going to be in between each hydrogen. That's the bonding pair of electrons. That's what's keeping them connected as a molecule. So I'm going to do this. I think this is right. So let's click on H2, and it shows here on the right basically the exact same thing that we just made. So cool. So here is our H2 molecule. All right, not too bad. All right, so let's clear this. Let's reset it. Let's try a harder one. Let's maybe go with this NH3. Okay, so we're gonna grab a nitrogen. H3 means we have 3 hydrogens. So let's grab 1, let's grab 2, and let's grab 3. Okay. Now remember that each of these single electrons, like on the nitrogen or the hydrogens, those are where we're going to make our bonds. That's where those connections are going to be made. So we want to basically pair up these individual electrons with each other to make these bonds. So like this hydrogen, I'd want to pair up here. Now this looks kind of funny. I think if I click on it, it'll move it up, so that looks a little bit more normal. So there we go. So I'm going to add a hydrogen there. That looks good. I'm going to move this one around so that it is going to be here. And if we bond that one up like this, I think that should make another bond there with that nitrogen and hydrogen. And then the last one here on the side. So let's move this electron over and let's put it right here. So when we're done, the nitrogen should have a total of 8 electrons on it. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. Remember the octet rule. The nitrogen's trying to get 8 valence electrons, just like everything else. The hydrogens are happy with only having 2 because they can't have more than 2. So this hydrogen has 1, 2. This hydrogen has 1, 2, and this hydrogen has 1, 2. So let's click on NH3. There we go. We see that this drawing here on the right, this structure, is the same as the one that we've just made. So, all right, cool. Which means we're doing it correct. All right. So we can clear that. We can reset. Up at the top here, if you click on double bonds, it'll bring you to a page with some more molecules. It's just that these ones have double bonds in them. So let's take a look at doing one of them. Let's do this. Let's do O2. Just to begin with, I don't want to do all the hard ones for you. I want to leave those ones for you to do. But let's grab in an oxygen. Oh, do we just click on it? Click on the molecule below to see how their atoms are bonded together. The first click forms single bonds. Click again to form double bonds. Okay, so do we? Oh, gotcha. Okay, so we just click on it and it just puts it together for us. The first click forms single bonds. Okay, so we clicked on it once. So this is forming a single bond. Now this is a single bond here because in the middle we have only 2 electrons being shared between the oxygens. That's a single bond. Now I know that this is not the final answer because if we look at each oxygen, like for example this one on the right, this oxygen has 1, 2, 3, 4, 5, 6, 7 electrons. Remember that it wants to have 8, right? Like everything wants to have 8. So it only has 7. The one on the left also has 7. 1, 2, 3, 4, 5, 6, 7. So I know that this can't be done yet because each of these auctions wants to have 8. If we notice, there's a single electron here on this auction that's not bonded, and a single electron here on this auction that's not bonded. I'm guessing if I click on this one more time, it's going to show those two electrons go together to make a double bond again in the middle. So if we click on it, okay, there we go. So we see those electrons move. So now we have two pairs of electrons being shared. So this would now be considered a double bond. Here's one bond between these two, and here's another bond between those two. And now if we count the total electrons on this auction on the right, we have 1, 2, 3, 4. Okay, these all count. So 1, 2, 3, 4, 5, 6, 7, 8. And then the auction on the left has 1, 2, 3, 4, 5, 6, 7, 8. So the octet rule has been satisfied. They show here this is a structural formula where instead of showing the dots as the electrons, they just show the bonding electrons as lines. It's the same thing. So there's a double bond, cool. And then triple bond, I'm guessing it's going to work the same way. I'm not going to click on it. You can do that when you want, but I assume if we click on N2, it will go through the whole steps of showing us how you make a triple bond. So anyway, like I said, just wanted to walk you through that. I will put the link for this simulation in the description of this video. And if you want to go through the other ones on your own, you certainly can. I would encourage it, especially if you need some practice on drawing Lewis structures. Just a nice, easy way to do it where you don't have to do it on paper, and then you can see if you're right. So, all right, guys, good luck. And if you have any questions, as always, make sure to email or message me. All right, thanks. Bye.